right, the thing about 8, and like all composite area problems, it's all about finding stuff that you know how to work with. It looks at first glance like there is no way you're going to come up with the area of that piece or the perimeter. They just look outside the box. So let's kind of get things started. Let's start writing down what we are looking at and seeing where we can go from there. Let's see, it says that the whole thing is 4 feet wide. All right, so that must be this measurement. 12 feet long, so that's this measurement. We're back to the study guide now. We'll come back to the quiz when we're done over here. I want to get through the entire study guide. I switched over to the quiz real quick because that was a very similar problem I knew people would have questions on. Now I've cut out some circles. Well, what do I know about how wide each of those cuts is? They have a diameter of 4? Yeah. So if this circle here, from here to here, if that's 4, what's the radius? 2. Just approaching this from this context of area, can I look at this thing as being a rectangle? That has had 6 half circles cut out of it? Or rather, let's make the math even easier. It's a rectangle that has had 3 full circles cut out of it, because each half circle corresponds to another half circle. So from that standpoint, I know the area of a rectangle. That's base times height, so that's 4 times 12. That's 48. The area of a circle I know is pi r squared. So that's pi times 2, not 4, 2 squared, or 4 pi, which is roughly the equivalent of 13, give or take. So now when I go to do the area total is going to be 48 minus 3 full circles, which puts me in the ballpark of 9 units. And then a little give and take there for rounding errors.
Well, if you did just use 12.56, then you would have got 10.32.
Okay, 10.32
Yeah.
is a more accurate answer. And that's instead of rounding this to 13, we use 12.56. All right, well, I'm good with that. But again, the concept here is the idea of taking that box, the rectangle, and seeing those 6 cutouts and identifying them as circles I already know how to calculate. There are not going to be a lot of problems where it's just, hey, here's the formula, go. But you have to have the formula to have success. Now when we do perimeter, again, it's not too bad of a problem. Just break it down into pieces. I've got 3 circles, or rather 6 half circles, and I'm adding on to that 2 segments. So that means what I'm really looking at here is 3 times the circumference of a circle, which is pi times diameter. So pi times 4 plus my 2 segments of 4 units each. Simplifies to 12 pi plus 4. And you should get an answer in the ballpark of, not 4, my bad, 8. Because there are 2 of them.
There's 2 what?
This is 4, and that's 4.
Oh.
So the 3 times pi times 4 tells me the total of this half circle here and this half circle. That's one of these pi times 4. And then this one is 2 of them. Here's my third. And then what's left are my 2 segments of 4 units each. And that's what gets me to my final answer of 45.68 for the perimeter. It's not easy. It's a lot of breaking the piece down into things you recognize and then proceeding. Because this isn't chapter 1 anymore. It's not just find me the circumference of a circle. It's work this stuff through.